Okay, so now we're going to do question 5, where we are given this function of f of x being equals to minus 1 over x minus 1, right? So 5.1 says that we must write down the domain of f, right? So when you talk of the domain, we're basically talking of the x values, right? So we are interpreting the movement of x values. So for a hyperbola, we simply write the domain as x is the element of real numbers, but x is not equals to 1. So we're going to use this vertical asymptote of x minus 1 here, right? So it's going to be x element of real numbers when x is not equals to 1. So this means now that the graph, the values of x move from negative infinity to positive infinity, but they do not touch x equals to 1. Fine. So now we're gonna do 5.2. We're going to write down the asymptotes of f, right? So the vertical asymptotes that we have here is 1, right? We're using this one, x minus 1. And then the horizontal asymptote is 0 because there is no value of q here, right? So these are our equations of asymptotes. Now we're going to do 5.3, which says that we must sketch the graph of f, clearly showing all intercepts with axes and asymptotes. So I'm just going to draw the graph on this side here. But before we draw the graph, we need to identify our intercepts. So when x-intercepts, y is equals to 0. Remember that we have our function f of x being equals to minus 1 over x minus 1, like that, right? Just to confirm, yes, that's how our function looks. So now we're just going to write our x-intercept when y is equals to 0, right? So it's going to be 0 is equals to minus 1 over x minus 1. So when you cross multiply x, so there's no solution of x and a, so there's no solution of x because when you cross multiply this, x minus 1 multiplies the negative, the 0, sorry. So there's no solution of x. And then y-intercept when x is equals to 0. So we're going to have f of 0 is equals to minus 1 over 0 minus 1 being equals to minus 1 divided by minus 1 equals to 1. So the y-intercept when x is 0, it's 1, like that, right? So we have our intercepts. Now we can draw our function. So what we're going to do is we're going to draw the function just right here. And we're going to label the function, or the Cartesian plane rather. So this is going to be your y and this is going to be your x. And remember that we don't have x-intercept, but we have y-intercept. Y-intercept when x is 0, it's actually 1, right? So let's say this is the y-intercept, 0 and 1, like that. And then our asymptotes, we have our vertical and horizontal, sorry, we're having our vertical and horizontal asymptotes. So our vertical asymptote is equals to 1, our horizontal asymptote is equals to 0. So we're going to identify our vertical asymptote, which is this one here, and say it's x being equals to 1. And then our horizontal asymptote is going to pass through here at y equals to 0. So looking at our function, right, this is our function, right? And for us to identify whether the graph is in the first or third quadrant or second or fourth quadrant, we must look at the value of a, which is this one here. So in this case, value of a is less than 0, meaning that the function is going to be in the second quadrant and fourth quadrant. Hence, if we draw, we're having one intercept here, so it's going to move like that and like that, and then the other part is going to move like that. So this is our graph of f represented in this problem here. Which values of x will x multiplied by the derivative of f of x be greater than 0, right? So remember that we drew our graph, right? Let me just redraw it again. So we had a graph like this, and our vertical asymptotes, x being equals to 1, horizontal asymptotes, y equals to 0, and that was the point. So our graph looks something like that. Right, so here we want to identify the x values, right, such that x multiplied by f prime of x, is it greater? Yes, it's greater or equals to 0, greater or equals to 0. So we want to identify the values of x when x, so this x here is actually y is equals to x, which can be represented, I'm sorry, speaking fast, which can be represented like this. So let's say this is y is equals to x, y is equals to x graph, right? So this graph multiplied by the slope of f, so this is f of x, right? So the slope of f means that we are literally looking at the gradient of the function of f, right? So where, in which point, so let me just label here 0 and 1, in which point of this graph here will we have a point where the gradient is increasing multiplied by a certain value of x will give us a positive solution of y. So we need that point. If we were to here the gradient is positive, here all the way up the gradient is positive, but here okay, it depends on how you interpret it. Yes, it just depends on how you interpret it. If you're going from bottom to up, then definitely the gradient will increase, right? Or if you, even if you consider looking at this straight line of y is equals to x, it is positive, right? The slope is positive, but we're not really concerned of the slope. So looking at the slope is positive, but looking at the x values in this section here, x values are negative, right? X values are negative, but in this section here, x values are positive. Why am I saying this? This is an x-axis, right? In this side of the x-axis, we're having positive x values. This side of the x-axis, we're having negative x values, right? So if you were to take positive values of x in the straight line, looking at this straight line of y is equals to x, if you were to take only positive x values which lie from the origin going in that direction, right? So we will have positive x values, right? And then you multiply by the gradient. So the graph is increasing, right? Whether you look at it in this side, whether you look at it in this side, the graph is increasing, right? So if something is increasing, it has a positive gradient, right? So meaning the positive x values, and the positive gradient will definitely give you a solution that is greater or equal to 0, right? So that is that. And if you were to include the negative x values, then you will need a point where the graph is decreasing to get a positive solution of y. But in this case, we're not interested in that. We're just looking at x values. When you multiply them with the gradient, it gives you a greater or equals to 0 solution of y. So I can simply conclude and say when x is greater than or equals to 0, right? So when x is greater than or equals to 0, so where is that? It is at this point here. X is equals to 0 at this point. But in that direction, x is greater or equals to 0. So when x is greater or equals to 0, but x must not be equals to 1, therefore you will have a situation where the value of x multiplied by the gradient of f will give you a solution that is greater or equals to 0. So that is the condition for us to conclude on this solution here. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.